Hi, I'm Sayed on Maths Online. The topic that we are going to discuss is solution of Lagrange linear PDE. Now, equation of this form capital P small p plus capital Q small q is equals to capital R, where this values of the value of P is nothing but dou Z by dou X. Q value is dou Z by dou y. This capital P, capital Q, and capital R are functions of x and y. Alright, so this equation is called as the Lagrange linear PDE. So, how to find out the solution of this Lagrange linear PDE? The solution of Lagrange linear PDE is Lagrange linear PDE can be written in the form of this auxiliary equation dx by capital P is equals to this dy by capital Q, and it is dz by capital R. Alright, dx by this capital P value, dy by this capital Q value, dz by this capital R value. So this equation is called as the auxiliary equation. So you need to first form the auxiliary equation, and either by grouping the first two equalities, or by the second and third equalities, or either by adding or by subtracting, you can solve this auxiliary equation to obtain the required solution in the form of 5 of u comma v is equals to 0. The solution of this auxiliary equation will be in the form of phi of u comma v is equals to 0. So the first solution you'll be getting will be u. The second solution that you'll be getting will be v. Now the solution that you get over here, u and v, has to be written in the form of phi of the value of u comma the value of v is equals to 0. So this will give the solution for the auxiliary equation, and this itself will be the solution of the Lagrange linear PDE. Now we'll try to see how to form the auxiliary equation, how to get the value of u, how to get the value of v, and how to write it in the form of phi of u comma v is equals to 0. So let us take the first question. Solve x into dou z by dou x plus y into dou z by dou y is equals to z. Solve x into dou z by dou x plus y into dou z by dou y is equals to z. Now we need to check whether this given equation is in the form of pp plus qq is equals to r. Let us first try to identify this one. We know the value of this dou z by dou x is nothing but p value, and dou z by dou y is nothing but q value. So already you have small p and small q. But this equation, this x will be acting as your capital P, this y will be acting as your capital Q, and this z will be acting as your capital R. So this equation is in the form of Pp plus Qq is equals to R. So you can write down the solution. The given equation is of the form Pp plus Qq is equals to R, where the value of capital P that you have, so that is coefficient of dou z by dou x, that is x value, because we know dou z by dou x is small p. Then your capital Q value, capital Q is nothing but the coefficient of small q, that is coefficient of dou z by dou y. So this value is nothing but yours y, that is q value. So q value is y. Then r value, right hand side value is z. So once you got the value of capital P, capital Q, capital R, so I'll write down the auxiliary equation. So the auxiliary equation will be dx by capital P is equals to dy by capital Q is equals to dz by capital R. Now write down the value of this capital P, capital Q, and capital R. So you have dx by capital P will be x, is equals to, it is dy by capital Q will be y, then you have dz by capital R will be z. If you want to obtain two solutions, that means you have to obtain this u and v. So to obtain u and v, you have choice. Either you can group the first two, obtain one solution, right, and choose the second and third, obtain the second solution. Or you have one more choice, choose the first and the third. Out of these three choices, you can choose any two, because you want only two solutions over here. So you can adopt any of the two results. So what I'll try to do over here is I'll just choose this as the first equation, this as the second equation. So I'll obtain the value of u and v from here, right, the solutions. So now let us consider dx by x is equals to dy by y. So this equation is in the variable separable form. So whenever you have variable separable form, you can integrate it. So I'll try to integrate this one. Integrate it. So if you try to integrate this one, you'll be getting integral of dx by x is equals to, it is integral of dy by y. So whenever you are trying to integrate, you need to add the constant of integration. I know that after integrating, I'll be getting both the results as log. Therefore, I'll be adding the constant of integration as log c1. And you know integral of dx by x will be log of x. Integral of dy by y will be log of y plus log of c1. So I'll just send this log y on the left hand side. I'll be getting log of x minus log of y is equals to, on the right hand side, constant, I'll keep it as it is, log of c1. This is in the form of log m minus log n, which will be log m by n form. It will be log of x by y form is equals to, you have log of c1. Now log on both the sides will vanish. You'll just be getting x by y is equals to c1. First solution. Alright. So this first solution will always be in the form of u. So it can be in this form. The general solution that you get, the first solution that you get, should be in this form, u of x comma y comma z is equals to the constant c1. This is the general solution that you have. So it should be in this form. So first solution has been obtained. Now I'll go for the second solution. So if you want to go for the second solution, I'll consider the next two equalities, these two equalities. So consider it is dy by y is equals to dz by z. Dz by z. So because you can see that these values are in the variable separable form, therefore we'll try to integrate this. Integral of dy by y is equals to integral of dz by z plus, both these integrals will give us log, therefore I'll be adding the constant of integration as log of c2. So this will be nothing but log of y. This integral will be nothing but log of z plus this will be log of c2. Log of z you can send on the other side, will be log of y minus log of z is equals to, it is log of c2. So once again it is in the form of log m minus log n, which will be log of m by n, that will be y by z is equals to, you have log of c2. Our log will vanish, you'll just be getting y by z is equals to c2. And this value which is there is in the general form. So this is in the form of v of x comma y comma z is equals to c2. So you should always get the solution of this form. So once you have got it, the final solution that you have to write is in the form of 5 of u comma v is equals to 0. This is how you have to write. U is the left hand side value and v is the left hand side value over here. So therefore, if I write down the solution now, therefore the solution is 5 of u value, that is the left hand side value will be x by y, comma, v value, that is this left hand side value, it is y by z is equals to 0. So this will be the required solution. Okay, so now if you go back to this, I told you that you can either take the first set of equation, the second set of equation, or you can even take this third set of equation. Suppose if we take the third set of equation, dx by x is equals to dz by z. In that case, we'll be getting the value as x by z is equals to, say, if I am taking one more constant c3, you can just try it. I'm just showing you, you will get in this form, because here in all the cases we have seen that the first value that I have taken dx by x, that has come in the numerator, the second value that I have taken dy by y, that has come in the denominator. So if I am taking the equation as dx by x is equals to, if I am taking this equation, dx by x is equals to dz by z, in this case the solution that you will be getting will be x by z is equals to some c3. Alright, so in that case, if you want to write down, suppose if somebody is solving in this way and you're getting this solution, if you have taken the first equation, I'm just showing you first equality and the third equality. In that case, for the first equality, you have got the solution as x by y. So you can get x by y. And for the third equality, you have got x by z is equals to 0. If somebody gets this solution, then the solution is right. This solution is also right, this solution is also right. But if somebody takes equality, I have taken first and second equality, you have taken first and third, suppose if you are taking second and third equality, in that case for second what you have got? You have got the value as y by z, and for the third you have got x by z is equals to 0. So this solution is also correct. Depending upon how you are taking the equalities, accordingly you are getting. If the first person gets this as a solution, it is right. If the second person gets this solution, he is also right. If the third person takes this solution, that person is also right. So these are the possible solutions that you can get. So now we'll take up the next question. Solve p times of cot of x plus q times of cot of y is equals to cot of z. You have to solve this one. So this is in the form of pp plus qq is equals to r. So here the given equation is of the form pp plus qq is equals to r. So identify the value of p, capital P. So what will be the value of capital P here? Capital P value will be cot of x. And what will be capital Q value? Capital Q value will be cot of y. And capital R value. So what is capital R value? Cot Z. So you got the value of PQ R. So we have to write down the auxiliary equation over here. So if you write down the auxiliary equation will be dx by P is equals to, it is dy by Q is equals to dz by R. That is the auxiliary equation. So you can write down, it is dx by, the value of P will be cot of x. It is dy by, the value of q will be cot of y, and the value of r will be cot of z. If suppose if I am choosing the first two equalities, I'll be getting one solution. Alright, then you can choose the next two equalities, you'll be getting the next solution. So if I am choosing this as a first set of equation and this as a second set of equations, you can get it. You can get the solution. If you want, you can even choose the first and the third also. No problem with that. So we'll consider the first equality is dx by cot of x is equals to, it is dy by cot of y. So integrate it. So if you try to integrate, we'll be getting integral of. Can I write this 1 by cot? Because we are having cot here. 1 by cot value. Tan you can write. So 1 by cot can be written as tan x. So I'll write tan x into dx. So 1 by cot is written in the form of tan x is equals. So integral of, again 1 by cot is there, I'll write as tan. So it will be tan of y into this dy. Plus you need to add the constant of integration over here. So if you try to add the constant of integration, I know that the integration of tan will be log. I have to add the constant of integration to be log of C1. So this value will be log of integration of tan will be log of secant of x. That will be equals to tan y will be log of secant of y plus this will be log of C1. Now if you take log of secant y on the left hand side, you will be getting log of secant of x minus log of secant of y is equals to, it is log of C1. Now this is in the form of log m minus log n, which will be log of m by n, which will be log of secant of x divided by secant of y is equals to, you have log of C1. So this log, if I cancel out, you'll be getting secant of x divided by secant of y is equals to C1. That is the first solution we have got. So let me take this as say equation number 1. Again consider dy by cot y, dy by cot y is equals to, you have dz by cot z, dz by cot z. So again they are in the variable separable form. We'll try to integrate this one. Integrate it. So if you try to integrate, it will be integral of 1 by cot will be tan. So it will be tan of y dy is equals to, it is integral of tan of z into dz. Because both will be log, therefore we'll be adding the constant of integration will be log of C2. So its integral value will be log of secant y is equals to. So its integral value will be log of secant z plus this log of C2. You can take this log of secant on the left hand side. You will get log of secant of y minus log of secant of z is equals to, it is log of C2. Once again, this is in the form of log m minus log n, which will be log m by n form. It will be log of secant of y divided by secant of z is equals to, you have log of C2. So log will cancel out, you'll be getting secant of y by secant of z is equals to C2. That is the second solution you have got. So let me take this as equation number 2. So now if you write down the final solution, therefore the solution is, you have to write in the form of 5 of u comma v. 5 of u is the first solution you got. First solution is how much? Secant x by secant y. Secant x by secant of y, comma the second solution, the secant of y by secant of z is equals to 0. So this is the required solution. Suppose if you are taking the first equation as it is, so we'll be getting secant x by secant y. Suppose if you are taking the first and the third one, yes, secant x by secant z is equals to 0. This, if somebody is getting this solution, then that solution is also right. That's all I have for today. Thank you.